Thank you so much.
And I have just polled everyone if they can hear you as well. So we can have a look at the poll.
Yep. A poll says 100% say no, and just 1% says yes.
Okay, let's redo the poll because it looks like. Let me try that again. Yeah, pretty much.
Yeah, perfect.
All right, over to you, Nitin.
Thank you. Thank you for the assistance there. So, good evening, everybody, and welcome to 360 DGTMG. My name is Nitin Mishra. I will be your host today evening for this webinar on F distribution. So, before we proceed any further about the F distribution, I would like to briefly tell you about myself. That is me, Nitin Mishra. And yes, I am that old. I'm a data scientist with the 360 DGTMG, and I have been associated with this organization for over 5 years now. I have done my graduation, and then I have done a course with IIM Lucknow as well. I am basically a mechanical engineer, and being a mechanical engineer with almost 16 years of experience in that mechanical engineering field. And it is recently, that is almost 5 years back, that I moved to the analytics field, and I've been with that. So that's briefly about what I am, and some of other aspects or facets of my profile for your reference. And this has been my career path. So I started off as a junior level quality control supervisor in a manufacturing setup, and today I'm a senior data scientist with Denominator and 360 DGTMG, both the companies. I'm part of that. So with 360 DGTMG, do the training part of it, and with Denominator we do the development. So that was briefly about myself. Now moving on to the topic at hand. So today we are going to be discussing about what is known as F distribution, and this F distribution is a continuation to the continuous distribution, that some of which we have already seen. So before we proceed any further, a brief note about 360 DGTMG. So we are a training service provider in the space of emerging technologies, in the space of newer technologies and skills that are now required, especially in the backdrop of COVID-19 pandemic. More and more upskilling, cross-skilling requirements are being, expectations are there, and people are working towards that. So we have been pretty much a forerunner in that field. And a certification or a training is only good if it is substantiated with some kind of an international certification. So we have City and Guilds, which is a certification recognized by the Queen of England, and it is that higher certification. University Technology Malaysia is a University of Malaysia. They have their SPACE, School of Professional Continuing Education, their online division. So UTM is in the top 100 universities of the world. And then, of course, we are certified through TUV SUD for our courses. So these are, excuse me, the bunch of certifications that a participant would get once they do a full-fledged data science program with this. But nevertheless, you can always attend our free webinars that are conducted almost 7 to 8 times a month, and you can learn a lot of things. So that's basically it. And this is, of course, just a sample visualization of how your certificate would look once you do our full-fledged course. So let us start the F distribution. F distribution is a continuation to the or F distribution is part of the continuous probability distribution. So we have two types of distribution. One is discrete and the other is continuous. Now we are talking about the continuous distribution. I'm going to assume that you have some basic knowledge about what distribution is all about, what is discrete probability distribution, what is continuous probability distribution, and therefore we are moving ahead with the next level. So you might have discussed, or you might have learned, or you might have read about the continuous probability distribution, or the Gaussian distribution, or the Z distribution. Now, this is a classic distribution wherein you have the zero, you have the minus infinity, and you have the plus infinity. So this is basically what it is. Now, everything is built upon certain fundamentals. So like you learn the counting 0, 1, 2, 3, 4, 5, and the entire advanced calculus resides on that fundamental. So normal distribution is that fundamental on which all the other distributions resides. So in continuation to the Z distribution, we have the chi-square distribution. Now, the chi-square distribution is the squared of the normal distribution. All right, and the continuation of the chi-square distribution is the F distribution, which is a series of chi-square distributions. Now, if you have one chi-square distribution, you have another chi-square distribution, you have another chi-square distribution, so on and so forth. If you have a series of chi-square distributions, that would follow what is called an F distribution. Now, I'm sure all of you are a little alarmed at whatever I have said. So rather than trying to make it a purely theoretical lesson, we'll try to understand the application per se of the F distribution rather than trying to get into the nuances or more of a statistics standpoint of view. All right, so let us quickly go into it. So this is named after R.A. Fisher, who did a research about this way back in 1924. So actually there were two people. As always, the second person's name is never known. Schnodder, it's a very difficult name to pronounce. So Fisher Schnodder thing, but because it is not called a FS distribution, it's simply called FS, so people know it as a Fisher distribution. So the purpose or the application of the F distribution is for comparison of variances of two populations. All right, and also terms as variance ratio is defined by terms of two populations. So let us quickly understand. So we have to first look at what is known as the F static. So you have here two things. One is the variance of group 1 and the variance of group 2. We want to compare these variances. Now, why would we want to compare variances? We would want to compare means. You have the X bar, or better still, you have the mu1 versus mu2. You want to compare that, right? So to set the context, we have, let us say, two populations. All right, and we have some data. I want to compare the effects of smoking on the longevity of the people. So I have a group of people who do smoke, and I have a group of people who do not smoke, and I have the ages at which they passed on. Now, I want to be able to compare this data with this data. Now, if I want to really do a complete analysis, I would have to speak to every single person who ever lived and died on this earth who did not smoke. And I'd probably need to similarly speak to every person who is dead who was smoking. So which kind of absurd and impossible to do. So basically, we'll have to go with a sample data. All right. So I have some medical records which states that these many people are no more. At what age they passed on, and whether they were smoking or not is the data that I have. Now, if I want to compare this, obviously the objective is to compare the average age between the two. So rather than trying to compare the mu of the smoker, let us call this one as the smoker and this one as the non-smoker. So ideally, I want to compare whether they are equal, they are less, or they are greater. This is what I want to do, but this is not possible. So I'll have to make do with now X bar smoker versus X bar non-smoker is the sample data between sample data of smokers versus non-smokers. This is definitely easy. Now, there can be instances and there can be times when even this data would be difficult to ascertain or obtain, and therefore we would want to compare the variances. Now, when we want to compare the variances, similarly, I would want to compare the population variance of smoker versus the population variance of non-smoker. I would want to know if it is equal, less than, or greater than, which again is not possible for the same reason that it is impossible to capture the population data. So once again, I have to make do with the sample. When I'm talking about the sample variance, it becomes represented by capital S, sample variance of smoker versus sample variance of non-smoker. Now we can compare. Now this is possible. So this is essentially the purpose of the F distribution. Now we may have so to understand this, the F critical value is given by this, which is either the sample variance divided by sample variance or the population variance divided by the population variance. So here we say 1 and 2, here we say 1 and 2. So this is what we have. All right. Now, all right. So next, we will. So what is this S1 and what is this S2? We have this formula here. Most of you are aware about the excuse me, about the formula of this sample variance x1 minus x1 bar whole square n minus 1. So what this means is that what this means, you are obviously aware of this particular formula. All right. So the F static is simply a ratio between the sample variance divided by sample variance or population variance divided by population variance. There is, of course, a small proviso, and that proviso is the numerator should be greater than denominator. The numerator should be greater than the denominator. All right. So moving along, in the if we are able to do it with the population variance, then no problem. But obviously this is not possible. So we obviously need the sample variance. We obviously need the sample variance. So we are for the sample variance, the denominator is n-1. So this is another concept that one must remember when we are talking about the formula for variance. Let me just quickly go to the previous slide and explain that a little more clearly about the variance, because that is a little essential before I proceed any further. Once again, it is expected that you are aware about the formula for variance. So this is variance, and variance is the spread of data basically. So it is the distribution between each and every value where you have, let us say, n values minus mu squared whole divided by n. So this is basically what we have. Let me just make this a little clear. Right. So this is what it is. If this is a clear-cut case of the formula, but when you have the same thing as the sample variance, the sample is obviously denoted by lowercase n, and now because we do not have the population data, we have to use the sorry about that. We have to use the sample mean, and ideally using the same formula. Now, whatever formula that you have seen here, for the same formula you will have n, but in the sample it is not n, it is n-1. We do not divide it by the sample size, but we divide it by what is known as degrees of freedom. So this is an essential part of the difference between excuse me, difference between population variance and sample variance. So as a thumb rule, the denominator for the population variance is population size, the denominator for sample variance is not the sample size but degrees of freedom. So moving on, the n-1 and n-2 are the 2 degrees of freedom represented by V1 and V2. And V1 and V2 are the parameters of the F distribution through which we are going to get the critical value. All right. So ideally, if this particular value sigma 1 square and sigma 2 square were equal, then that is what is the meaning of equal? The whole objective of the entire study has been to find out if the variances are equal. All right. And when I say variances are equal, it is for the population. And once again, we do not know the population. So using the ratio of the variances of the sample, by finding out a F critical value, we are going to conclude or we are going to infer whether they are equal or not. That is the whole objective of this particular study. All right. Now, this is, of course, the probability distribution function, wherein you have the probability values associated with each of the values. Of course, this is not so essential. We will not get into that. We'll just look into the probabilities of the F distribution. It is rightly skewed, and it is always positive values. All right, and F value may be positive or 0, as the variances are squares. All right, and shape of distribution relies on the V1 and V2 values. So what we will do is we will look into some details of the hypothesis test and take a particular case. All right, so let me use a blank screen. Okay, I'll use this screen. Yeah, so let me use this whiteboard. So how does the F distribution look like? Now remember, I told you it is a summation of the chi-squares. We are talking about the square of the distribution. So a distribution which is like this, which is what we have so used to, becomes something that starts from 0. It rapidly increases, and then that's supposed to be a smooth curve. I'm sorry about that. And it goes all the way to the end. All right. And as always, the area under the curve below this entire area under the curve is equal to 1. That is, of course, but given. Okay. Can probably erase that. And then, most importantly, we are talking about the F critical value. So the area under the curve from this point onwards is equal to alpha, and the standard values of alpha are 0.05, 0.01, 0.1. That is 5%, 1%, and 10%. These are the most popular values of alpha that we are going to be looking at, and nothing more than that. All right. So now how does this work? All right, how does this work? Let me just quickly try to explain it in this format itself. All right, because okay, so I told you we have I told you we have two values V1 and V2, which is nothing but N1 minus 1 and N2 minus 1. These are the two degrees of freedom. All right, degrees of freedom 1 and degrees of freedom 2. This is the ratio that we are going to be looking at. So when you have the tabulation for every critical value, all right, for every critical value, let us say we have the F distribution. Yeah, this kind of turned out well. So if I want the alpha value is equal to 0.05, all right, if I want the alpha value is equal to 0.05, then this is the F value, which starts from 0 and goes all the way to infinity. Now, this F value is a standard value for various combinations of degrees of freedom 1 by degrees of freedom 2. Now, what is degree? Actually, sometimes it is represented as V1 by V2 or N1 minus 1 by N2 minus 1. Now, when I'm writing this as n1 minus 1 and n2 minus 1, it is not the, what shall I say, the answer of the, it's not the fraction that we are looking at. It is just n1 minus 1, thus that upon this. All right. So suppose I have, let me just keep this distribution a small one on the top. Okay. All right. Now, this is 0 and this is infinity. There are only positive values. All right. There are no negative values because it is a squared thing that is very much there. Now, suppose I have one population of which I take a sample of, let us say, 10 values. And I have another population of which I take a sample of, let us say, 6 values. So the degrees of freedom is equal to 9 and the degrees of freedom is equal to 5. So I have, for various F distributions, you can simply Google it, and probably if you simply say F distribution Google, so you will have on the horizontal axis df1, on the vertical axis df2. So if you look at the table, it will be 1, 2, 3, 4, 5, 6, all the way to infinity. And this will be 1, 2, 3, 4, 5, all the way to infinity. Now, I am on purpose not showing that because I expect you to figure it out yourself. Let me draw it out like this again. So we have df1, df2, now this particular matrix will have a lot of values. Now remember, we were talking of df1 is equal to 9 because they were 10, and df2 is equal to 5 because they were 6. So we are looking at, let us say, 9 and 5. The value that we have here, let us assume we have a value 4 point. Let me not mention 4.9. Let me say the value is x point y f g. Again, because I don't want an image, I don't want the number to be things. X point y f g is that particular value. So now this area of 0.05, this value of f will be x point y f g for 9 by 5. Now, if you have something else, let us say 10 by 16, it will be some other value. 8 by 3, it will be some other value. 2 by 5, it will be some other value. Whatever that f value is, this area will be equal to 0.05. So this is the tabulation. This is how the table will look. The f table will look with all those f critical values. Now remember, this is for alpha is equal to 0.05. You can have alpha is equal to 0.01. You can have alpha is equal to 0.10. Now these are the standard values, standard alpha values for which in the tabulation you can have the f values. But you can also have, obviously the question would be, what if alpha is equal to 0.03? Yes, you can do that. Luckily, we live in the age of internet and various online software. So you can Google f value calculator, just Google f value calculator, and then you can look into that f value for the various values of alpha. And obviously the entry values would be, so when you open this, any of these Google tools that you use, it will tell you what is the alpha value, what is the df1, what is the df2. You enter these three values and it will give you the F critical value as the output. So this essentially is what we are doing. Now, this was all too much of theory, I realize. Now, what is the application? How do you do it? How do you actually make a decision? So I will try to explain it. Please, try to follow me because it may take a little more concentration to understand. So, 1 minute, let me draw it once again. All right. So let us do a standard alpha is equal to 0.05. That is the significance level that we are looking at. Okay. Now I want to know the value of F for, let us say, degrees of freedom. Nine and 5. So I have taken two samples from two different populations. What is the sample? For these two samples, I have the variances S1 square and S2 square, some value. Now, if I calculate the ratio of S1 square by S2 square, and I will call this F calculated. All right. So assume for a moment this critical value of F is 3 and this ratio is 3.8. What is this 3? Let me repeat once again. This 3, again, I'm saying assume, because I am not opening the F table and showing it to you right away. I want you to also do something at your end. So I'm not opening that. So I want you to assume. So let me clear it up. So I have F critical is equal to 3 for df1 is equal to 9 and df2 is equal to 5. Let me say assumed value is equal to 5. And another thing most important is alpha is equal to 0.5. Now, this also means that my N1 was 10 and my N2 was 6. So for a sample size of 10, I might have some values, x1, x2, x3, x10. And for sample size of 6, I may have values y1, y2, y3, y6. For this sample, I can have the S1 square value. And for this, I can have the S2 square value. Now, when I take the ratio, so this is the F critical value. Which I have said is 3. And the F calculated value is S1 square divided by S2 square. Let us assume this value is 3.5. So now I'm going to erase my screen and only look at these two values, 3 and 3.5. 3 once again is using the degrees of freedom and 3.5 is using the ratio between the sample variances. Now, when I plot this in the F critical value, in the F distribution, this is 3. And the value that we have got is 3.5. Now, we know for a fact that this area is 0.05 because we already established that alpha is equal to 0.05. Therefore, this value now is something that is less than 0.05. Obviously, it goes without saying that because my calculated value, so because my f calculated value is greater than f critical, the p, because this is nothing but p is less than alpha. We already are aware about the hypothesis, and the null hypothesis is always the equal to. So sigma 1 square is equal to sigma 2 square. And the alternative hypothesis is not equal. So if I look at the alternative hypothesis, sigma 1 square is not equal to sigma 2 square. Let me clear it up. We have already studied adequately about the hypothesis testing and what is expected to know. So we have two simple rules of the thumb, which is P low, null go, reject null hypothesis, P high, null fly, fail to reject null hypothesis. Now let me draw this small f distribution here. So this is 3, 3.5, this area, so this p value less than 0.05, which means this follows the p low null go reject null hypothesis, which means our assumption that the variances of the population are equal is incorrect, and in reality our test suggests that the variances between the populations, based on the sample data, the variances between the population is in fact not equal to each other. This is the inference that we draw. The corollary to that is keeping the same critical value f critical value assume as 3. If my s1 square divided by s2 square had been a value 2.8, we all know this is 0 and this is infinity, so 2.8 would be somewhere here. So the area under the curve towards the right hand side from the point 2.8 to the end is going to be greater than alpha, and in this case 0.05. So in the previous slide, because it is high, so P high null fly fail to reject null hypothesis, which means my assumption that the two variances are equal is acceptable. This is the application. This is the entire simple math. Now, for want of time, I'm not taking up, a physical example. Also, because I would want all of you to, have something to go back and actually look into it. So, first things, what you can do is, it is very easy for me to open the, browser and show the F table and look at it. But I want you to basically experiment it on your own. Open the browser, figure out, just open F table, and then check out the various F tables. So there will be alpha is equal to 1%, alpha is equal to 5%, alpha is equal to 10%. These are the standards. Sometimes they may have a couple of more. So we'll have multiple tables for each alpha value, and each of those tables will have values pertaining to the various distributions, the various degrees of freedom. All right. So that is one thing I want you to do. And the other application of, the biggest application of the F distribution is Anova. So here we were talking about variance 1 is equal to variance 2, but we may have scenario of variance 3. Excuse me. So in Anova, which stands for analysis of variance, analysis of variance, this is what Anova stands for. We may want to compare so on and so forth, and this will be your null hypothesis, and the alternative hypothesis will be, we cannot really write them as all are not equal. You can also have one equal, rest not equal. So variances are different. That will simply take care of everything. Variances are different. So that is the biggest application of the F distribution table. And yep, so that kind of concludes my discussion with reference to the F distribution. The mean of the F distribution, there is a formula. Basically, we already know what V1 and V2 is. V1 and V2 is nothing but the 2 degrees of freedom that we have already discussed here. So N1 minus 1 and N2 minus 1. All right. And so the whole F distribution relies on these two values, V1 and V2. And the shapes of the distribution will change upon those things. So this, of course, is the formula for the mean of the distribution, and the variance of the F distribution is given by that. So that's basically what it is. And like I said, this is what we were discussing. So if you want to compare the equality of two variances, the null hypothesis states they are equal. So the F static or the F critical value is either the sample variances by sample variance or population. Obviously, population variance is not possible, so it is this value. And using V1 and V2 degrees of freedom, we use the F table to find the F critical value. So F static and F critical. And if the particular value I've already mentioned, if the F calculated value is greater, we reject the null hypothesis. If it is lesser, we accept the null hypothesis. So that is effectively what it is. And the objective has always been, our modules, the objective has been to, make the sessions as crisp and small as possible. The objective is not to, make the session really boring and 2 hours, 3 hours long. So this is a very small module. Now, the objective of this session also is to raise more questions than answers. Now, you are definitely yearning to find out what is Anova and how Anova will be working. So that will be part of our ongoing webinar series. So where we will explain as a continuation to this what is Anova and how to use that particular application of the F distribution, and also some case studies and samples, some numerical exercises of the F distribution. So I hope all of you had fun. So I would request you to kindly, get in touch on our social media platforms. We are live, and you may want to get in touch with us. And thank you so much. If there are any questions, I'd be willing to take them. Thank you. Thank you. Um, I'm not able to see your messages. I saw one message, but
Hi Nitin, I think Mr. Faisal has a question, and the question is, how did you assume the first F?
okay. Faisal, I once again I'm telling you, I am not going to open the. Uh, all right, let me just answer that and then I'll explain to you. So I want you to Google while you are talking to me, while you are looking at this, and say F table. All right. This is also a part of the learning. I want you to Google F table. And then in the F table, I want you to look for alpha is equal to 0.05. Now let us do this live. Can you please look into the F table and tell me what is the value with df1 is equal to 9, where df1 is the horizontal axis 1, 2, 3, 4, 5, 9, and df2 is equal to 5. 1, 2, 3, 5. So basically, I want you to tell me the intersection of this value. I am assuming, because I don't have the table open to me, I'm not going to open the table. I am saying this value is 3, and I kept saying assume. But this value will be 4.7 or 8.8 or 7.9. I don't know because I don't have the table in front of me. Do you understand? But can you look at that F table and figure out that value? I have it open in front of me, but I'm not going to tell you the value. I want you to, kind of figure it out. For alpha is equal to 0.5, 0.05, my bad. Why am I not able to see the chats? I'm only able to see few of the messages. The remaining messages I'm not able to see.
Well, I will help you in this, Nitin. I can see Mr. Faisal has replied as the figure 3.3.4817. That's the value he has set for F value.
No, I think you are looking at alpha is equal to 0.1.
Bindu, Bindu has a reply for this question. She says it's 3.31.
Alpha is equal to 0.05. Alpha is equal to 0.05. Let me tell you, the answer is 4.77. In fact, while I was giving this thing, I accidentally mentioned the answer. It is 4.77. Please look at the table correctly. When you open your F distribution on the web, you will see F table for alpha is equal to, okay, let me share the link. You can probably, use that. 1 minute. Yeah, I'm not sure if I have. Is everybody got that link or not? Can you please open that link?
Yes, Nitin, everyone has got that link.
Okay, can you please open that link? And when you see F distribution tables, the first table is alpha is equal to 10%. And there, for 9 by 5, for 10% is 3.316. But I asked for alpha is equal to 0.05. So you'll have to scroll down. And when F table for alpha is equal to 0.05, the value is 4.772. How many of you got it? Yeah, Amit Faisal got 4.77. You got it? Everybody got it? Right, now I'm able to see the message. Somehow it was hidden. So yeah, all of you got it? Jocelyn also got it. Perfect, perfect, perfect. So that is, see, what I had mentioned as 3 here should have been 4.772. I on purpose mentioned that there. All right, now let me correct it. Now this was the F value that we got using the table. Now for the same n is equal to 10, sorry, n1 is equal to 10 and n2 is equal to 6, we will have the sample data. For that sample data, we'll have the variance. For that variance, the sample variance, so S1 square and S2 square. If I take the ratio of this, and if this value had been, let us say, 5, let us assume for a moment, this value is 5. Then in the distribution, so you get the value P less than alpha, and that is K. Is it clear, friends? P low, null go, reject null hypothesis. Therefore, our assumption that the sample variances is equal is not acceptable. They are different. Crystal. Okay, perfect. Thank you so much.
I think one more question is there for you.
Where is that?
So, Mr. Pratik. So the question is, there are different distributions like Z, T,
Yeah, I saw
and
that. There are distributed Z, T, and F. How find which is best? No, there is no. I'm very sorry. There is nothing like this is better or that is better. Every distribution is equally important. It is based on the application. Now, I think I recognize Mr. Pratik. Pratik is, I think, already a student of certain classes. So we use the Z distribution when we have a population data, for instance, the population variance. Then we use the Z distribution. When the population variance is not known, we use the T distribution. When the objective is to compare the variances and not the means, the Z and T distribution is used for means. When the objective is to compare the variances, we use the F distribution. Am I clear? Am I clear? So if the calculated is less than the F value, how do you reject? You accept. If it is less, remember it is kind of counterintuitive. See, if it is less, this is 0, this is infinity, this is your distribution, this is your, let us say, I will call it F table from the F table, and this is your F calculated. So what happens if F calculated is less than F table, then P is greater than alpha. So P high, null fly, failed to reject null hypothesis, you accept it. That is pretty unlikely. We have a question here. So what if it is equal? All right, F critical and that thing is equal. So you basically need to probably look at see if suppose the good thing about hypothesis testing is that if you are having, let us say you have taken the F value at 0.05 and you have done this analysis, and if you are not able to conclude with 0.05, you may want to either downgrade the the confidence to 10%, that is from 5% confidence or 5% significance to 10% significance, or you may want to increase the significance to 1% and then take your decision. If in an extreme case where your F value calculated and F value critical is exactly the same, then you may want to use a different alpha altogether. Did you understand, Mr. Mr. Faisal, that if the F value is calculated value is less, you actually accept the null hypothesis, not reject it. Only if it is greater, you reject it. All right. Okay, so thank you so much. I think if there are no further questions, we shall close for today. And please be on the lookout for further such webinars for your benefit. All right. Thank you so much.